you turned it off. There's one which charges no matter.
Oh, very good.
Wow, you can see the heat rising on the display. It's pretty warm in here. Okay, yes. Hi, I've already spoken to you. We've swapped two talks around because Jeff's late. I'm going to give you this talk, which is kind of the electronics talk, but it's really about the kit that we give you. Yeah, so I'm Rob. I'm a PhD student here. I'm just starting my 9th year of being a university student, which is interesting. I did my undergrad here as well, in electronic engineering. And yes, so this is my 7th year student robotics. Yeah, it's pretty insane. Yeah, so just to give you an idea of who I am and things, I thought I'd show you a project I did earlier this year in my back garden, which involved, I decided I wanted to build a glass blowing furnace. So we built one. There's a hairdryer on the end of that tube, and it was pretty good, pretty fun. I think the reason that I do student robotics, and I think the reason that a lot of the blue shirts do student robotics, is that we're passionate about engineering and doing stuff, building stuff, breaking stuff, and so on. It's not just something that we might do as a job. We do it in our spare time, things, because it's fun. And I really hope that this year you get just a sort of taste of some of that fun that you can get from engineering and all the things around it. So first, before we go and look at the kit that we're going to give you, I want you to think about what the major components of a robot are. Okay, you know what the robot's going to do. I want you to think about what the major components of that robot are, and I'd just like you to take 2 minutes talking to probably 3 people, 3 of your neighbours, about that, and just so come up with a list of like what the major components of the robot are. What are the things that you're going to have to spend time on, and maybe order them according to how long you think you're going to spend on each one. So go.
I can see us needing an Arduino because that helps sensors.
Right.
There's no point in them.
So I want you to just keep that list of things in front of you, and just at the end of the talk, we're gonna look back at it, and hopefully you're gonna think about. And at the end of all the talks today, I want you to think about how your perception of those things have changed. Okay. So robots in general, right? Well, probably the robots that you'll see in this competition in general, are made up of 3 sort of separate things, genres of things. You've got the mechanics of your robot, you've got the electronics, and then you've got some software that runs on top of those, on top of the electronics. And the electronics generally operates some kind of mechanical thing. So those things are kind of stacked on top of each other. You need mechanics for your electronics to be useful, and you need software for the electronics to be useful, and so on. The thing that most people don't really realise, perhaps, is that software is the most complicated part. As a human race, we've been building mechanical things for a long time, and software has only been around for I don't know, 60 years, something like that. It's still pretty difficult. And it hasn't really got much easier because technology gets more complicated as time goes on, exponentially. So anyway, the thing that you need to be aware of is that the software is going to take ages. And if you want to kind of try out the software things, I imagine that most of you haven't really written much software before. And so you're probably going to get it wrong. In fact, any engineer would get it wrong many times first before they got it right. And so what you really want is to get your mechanics and your electronics as robust as possible, so you don't have to spend all of your time fixing them when you really need to be working and spending your time on the software. Because often the software is the thing that gives your robot a brain. It is the brain. Okay, so what I want to do is I want to take you through a tour of building some kind of conceptual robot. And this robot I want to build is to drive around, and it needs to pick up things. I don't really care what they are at the moment. That's what I want to build. So in the next talk, you're going to hear about like putting motors and things on your robot and stuff like that. But this talk's mainly about the electronics. So imagine that we have a robot base. It's got 2 wheels, it's got 2 motors, and probably underneath the front here it's got a caster or something. So you could drive around with this thing. Right, so what we've got 4 wires coming out of it from motors, and we want to put those into some kind of electronics. And part of the kit that you get contains this thing called the motor board. And you get 2 of them, one for each motor. So, how do you connect it up? You need to go and look at the documentation on our website to find out how to connect it up. And our website, which you probably, hopefully come across, is, I'll fade into the computer, hang on. Yep, there I am. So, studentrobotics.org, or srobo.org for short. You go here, you click Docs, and now you'll notice down the left-hand side you've got this menu. I want to draw your attention to the fact that there are these 2 sections. One's called Kit, and one's called Programming. And for every board in the kit, let's say the motor controller, there are generally 2 sections that you want to look at. One's in programming about it, here you go, motors, and there's one up there, kit, that says motor board. And the kit one will tell you how to wire it up, how it works electrically. And the programming one tells you how to actually do some stuff with it, with software. So we go there, we see a nice picture of it, and we get this diagram here, and we see there's this big green thing at the top, which is the power connector. So we're going to need to connect some power in there. And on the right, there's the motor connector. So we want to connect the motor to that. So we go and, oh yeah, we also need a battery. Let's do that. So we needed something to plug into the power socket. Now we need a power source for that. And part of your kit is a battery. In fact, you get 2 batteries, so you can charge one while you're using the other. And I just want to tell you about batteries for a bit. Mainly because I value your lives. Batteries store energy. Just like a car uses petrol to store energy, your robot will use a battery to store energy. And the thing is that when you cram loads of energy into a small space, you have to be careful about how you treat it. Just as if you set fire to some petrol, it's going to be quite a dangerous situation. If you mistreat the batteries, you will get into a dangerous situation. Now, what is a dangerous situation with the batteries? Now, you're all used to batteries in your phones, laptops, maybe, I don't know, maybe you're come across AA batteries. I don't know, is there anything used in these days? Maybe. All of those things, they kind of wrap the batteries in this sort of layer of safety. When your laptop discharges its battery, it knows when it should stop taking power from that battery. Because with this type of battery, if you discharge it too far, it breaks permanently. And what our kit will do when that happens is it will start beeping at you when you stop to that flat point. And you need to turn it off then. Very important you turn it off, otherwise your battery is gone and you need to get a new one. And that's fine. Just turn it off when it beeps and you'll be fine, your battery won't break. That's the first thing. Second thing you should do is not drop your battery. Don't drop your battery, don't heat it up, don't puncture your battery, don't put it in water, because all of those things can lead to basically it exploding. And I know that sounds fun, but it really probably wouldn't be a very good end to your day. So this year also we've got these, in your kit you'll find some bags, we call them battery bags. And these are bags for storing batteries in, and also for charging them in. What these will just keep, if anything bad does happen to the battery, then the idea is that they contain any fire or anything that happens. And in finding these bags, we had to actually test them, right? So unfortunately, we don't have a video of the first test, because that didn't go too well. We got a very cheap bag, and it didn't go too well. How do you test these bags? We decided, okay, let's do a worst case scenario. What happens if someone connects the wrong type of charger, essentially, to this battery? Let's see what happens. Oh my god, it's a video and a presentation. Yeah, so there's your bag. Your bags look a bit different, but basically the same. And then off to the right, we've got a power supply that's just feeding it power. And on the first bag that we tested, which cost about £2 or something, the entire bag caught fire after causing a sort of jet of flame this long to come out of it.
That sounds cool.
That wasn't very good. But so that entire the fire of this battery has been quite contained, and it's just emitting some smoke. I thought we'd show you that so you don't have to do that yourself. And there are loads of videos on YouTube of these batteries catching fire and so on. But obviously, we'd like the batteries back from you. So, yes, please don't do that. Yeah. I think that's the end of that, really. Yeah. Another part of your kit is battery charger. So you can charge the battery. These chargers can be programmed to do different things. You only want to do one thing with it, but the documentation has a very clear checklist of things that you need to do to get your charger to program to charge the battery. And you just go to the docs, you can go to batteries, and here are the instructions on how to get it to charge the battery. And yeah, one point you should pay attention is that it says it asks you to confirm something, and that's actually confirming that it thinks what's going on is what's actually going on. Really, you should pay attention to that. Okay. Okay, so we've got a base with battery on and 2 motor controllers. Now our robot needs a brain. We want to actually get it to do something with those motors. So in your kit you'll find this thing we call the power board. And it's got this nice display, it's got these 2 dials. On-off switch, that's the on-off switch for the robot as a whole. And basically everything on your robot plugs into this thing. And it's got a fuse on the right as well. Okay, but inside that, it's got something called a beagle board. I normally wave one at you, but I don't have one. It's about that big. And this is a little computer. This is where all of your software that you're going to be writing is going to be running. On it, it's got something called an ARM processor, and it's running Linux. Have any of you heard of the Raspberry Pi?
Yeah.
Yeah, kind of, yes, good. Yeah, that's been in the news quite a lot recently. There's a lot of media stuff going on about it, because it's quite cheap. Well, it's a very cheap platform to do computing on, a little thing you can buy and do some, run some programs on. I thought I'd just show you a comparison between Raspberry Pi and what you've got here. And so what most people tend to do with these things is they'll go, oh, the Raspberry Pi runs at 700 megahertz and the BeagleBoard runs at 600. The Raspberry Pi must be better. But that isn't actually the case. For a long time now, clock speed hasn't really told you anything about performance, really. The thing, you need to look a bit deeper. Like the Raspberry Pi has got quite an old ARM chip on it. It's got one that was sort of launched by ARM, I think, in about 2002. Whereas the BeagleBoard has got one that was launched in about 2005. And then you actually run a benchmark on them, like a piece of software which tries to see how fast the thing is. You find that the BeagleBoard can actually do about twice as much as the Raspberry Pi. So, but you also have to remember that the Raspberry Pi is a lot cheaper than BeagleBoard. BeagleBoard's about £100, and Raspberry Pi is 30 quid or something like that. Yeah, so maybe that will interest you, don't know. Okay. So now you've got your power board, and you're going to write a program, and Sam's going to tell you about that later. And the result of that will be that you'll have a USB key, which is in the kit, with your software on it, and you plug it into the power board, and you turn your robot on, and it might do something that you want. Do we have a robot yet? We've got some wheels that can drive around, and we've got a brain that can control them. Maybe we might have a robot. It's a difficult question to answer. I mean, what is a robot? I mean, you could write a program that just turn the motors on for 3 seconds and then turn one on for 1 second to try and do sort of timing-based driving around. And that might work once out of 100 times. And you can do better. You can do a lot better. So what we want to do is we want to get some information from the outside world into the robot so that it can respond to it. So it goes, if it's driving along and it starts to veer off course, it can correct itself. So in your kit, you'll find a webcam. And we're not going to just give you a webcam and expect you to suddenly go, oh yeah, we'll just write this load of software and then it will be all sorted. Because computer vision is really tricky. You need to know a fair amount about what's going on. So we provide you with a software library that you can use, you should use, to see stuff in the arena. Now, where's my token here? You saw earlier that this token, it's got these markers on them, these things we call markers on them. Now, you've probably seen QR codes around the place. They're kind of like QR codes, but they're not QR codes. They're our own system that hopefully allows us to be able to see them from further away and things. And what you find is that the arena is absolutely covered in different markers. And the cool thing about the markers is that they each encode a number. For example, this marker is number 41. What 41 means, if you look in the specs for the competition, it means that it's a token. Whereas, say, that marker on the wall, the arena, that's a different number. I don't know what the number is off the top of my head, but that number would mean that specific marker in that place in the arena. So you can use those markers that are around the edge of the arena to work out where you are. Like sailors would use the stars, you can use the markers around the arena. Also, you note that the robots have got the badges on, with the little markers on, and those markers again, those ones say, I'm a robot. Okay, so if everything works, we will be able to show you the demo. So it's quite dark in here. This is too dark, and we had this problem last year. So I brought a solution to this problem, which may improve the situation. Although it's pointing at the screen. Try and not blind you, and also make it so you can see the screen. Yeah. Okay. So hopefully we've got sort of reasonably well lit room, which is what I recommend. Take my marker in. I put it down. I put it too bright there. Okay. Oh, this is too bright. Maybe I'll turn it on and see what happens. Okay. Yeah, we've got a bit of a lighting. Okay, you can see what some of the markers it's recognizing. It's quite dark, which means that the image is very noisy. So sometimes it will see the marker, sometimes it won't. Hopefully you can see that this marker here is flashing the SR logo back and forth. Oh, you can turn the lights on. Yeah. Yeah. So you can see those two. The other one is too much of a steep angle for it to recognize. And you can run that code that finds the markers on your own on the power board. And what's exciting about our stuff, is that it tells us things about that marker. Firstly, it tells us the number of the marker. It tells us where in the picture it is. So like, it's this many pixels this way, this many pixels down. But then the library that we provide you with also does some other cool stuff. It will it does some maths to work out, knowing what type of camera you're using, where in space that marker is, how many meters away it is, how and what angle it's at, and things like that. So here you can see, well, this one's easiest to look at right now. The distance to that marker, it reckons it's about 2 meters from here, the camera I've got here, is to this marker, which is about right. Obviously there's noise on that measurement, you see it's kind of flickering around, something you have to deal with. And last thing I need to tell you about vision is that because you're running it on a embedded processor, like the ARM chips that are in the Beagle board. They're significantly slower than my PC, laptop, whatever. So it takes some time for them to actually process an image when you get it. At the moment, it takes about 350 milliseconds to process an image at the default resolution. And you can change the resolution, but by changing the resolution of the image you take, you have to make some trade-offs. If you take a small resolution image, you can't see markers that are really far away. If you take but you can process them really quickly. But if you take a really high resolution image, you can see markers that are far away, but it takes longer to process that image. So you've got some things to think about there. Yeah, we covered that. And we kind of work on the vision throughout the year. Since last year, like beginning of last year's competition, it was 1.5 seconds per frame. Now we're down to about 350 milliseconds, as I said. And since the competition, we also detect the detection of the markers has improved quite a lot. You will see a lot more than we've done before. Enough about vision. So Now I want my robot, which can see and has wheels, I want it to be able to pick up something. So I'm going to build an arm. This is the arm. It's got two rigid bits, and I'm going to need some things to put at the joints so that it can move around. And let's say that I choose to use something called a servo. Maybe it's a good idea. I don't know. Try it out. See whether it breaks. This is a servo, and what these do, they're often used in remote control cars, and you can get them to set the arms on the top to a given angle. You can say move to 100 degrees and it will move. Move to 200 and move somewhere else. And in your kit, conveniently, there is a board called the servo board, which you can plug servos into, and from your software you can tell them what to do. So now you put the servos on your arm, you can control them, stuff. The last thing I want to do with my robot, I think, is once I actually grab something, I want to know when to stop kind of crushing it. So I'm going to put these little switches on the ends of my pincer, which are going to detect when I've actually reached the surface of the thing I'm trying to pick up. And you can connect those switches that are on the pincer to the final board that's in our kit, which is called the joint I/O board. And from your software, you can read those switches whether they're being shut or not. Now, those switches would be, if they were just a switch which turned on or off, you know, closed or open when the pincer was in contact or not, they would have a binary output, digital output. But the joint I/O board can also read analog signals. So it can read, if you have like a voltage, a variable resistor or something, you could measure with it where in its turn that variable resistor was. And there's a lot of things that you could connect to the joint I/O board. Far too many to go into now. And okay, so that's the kit. But you're free to build whatever you like around the kit. Build anything you like, really. You can build, if you want, you can build some custom electronics. If you wanted, you could use an Arduino. Has anyone heard of Arduino? Good, okay. Now what I want to make you just aware of is that Arduino is kind of the one that all the hype's around. There are a lot of other boards which are, firstly, there are a lot of boards which are compatible with Arduinos, so you can run the same code on them, and they actually take the same like daughter boards that you plug into them. But you've got an Arduino on the left there. Let's see if I can get these. That's the rugged Duino, it's the AVR Duino, that's the SB3 Duino. Then we've got the Seed Duino, the Olimexino. And those are the Arduino type ones, and there's a lot of them. There's a Wikipedia page this long with variants of the Arduino on them. If you were to choose one, if you wanted an Arduino one, I'd recommend the one at the top right. That's the rugged Duino. That's the one that's least likely to break if you do something wrong to it. A lot of people break Arduinos all the time. And then you could buy another type of development board, perhaps like this one, which is an mbed, or this one, which is a STM32 discovery board, or a MSP430 launchpad board. There's a lot of them out there, and take a pick, really. Yep, this is build your own. Where am I? Yep, okay. So, and I have 3 more slides, including this one. In the final year of my undergrad degree, so 4 years ago, Steve, he's undergrad at the same time. Steve's really old.
Cheers, man.
We, in a group project, actually with Steve and Jeff and me later and some other people around here, we built some really tiny robots. Those things are actually like that big on the side. And the idea was that we were building a swarm of robots so that we could do some stuff, and interesting things with swarms, really. The goal of this project was to build 25 identical robots. Okay? And we were trying to build identical robots. Okay? And we tried really hard to do that. But what we learned from this project was that you have to try really hard to get robots to be the same. Like each one of those, even though they were programmed the same thing, had the same circuitry, had the same design, they all behave differently. Like some of them would be could drive across this room in like 4 seconds, even though they're this big. Whereas other ones would just kind of limp across the room. And I wanted to share that with you because I think that even if 2 teams in Student Robotics built identical robots, they wouldn't be the same really. I don't think it's actually possible for them to be the same. And I just wanted to use that to try and encourage you to share your ideas with each other. Because even if you share your ideas with someone else, they're not going to be able to build a robot that's the same as yours. Finally, I have to finish with the standard 2 things, which a lot of people it's not intuitive to people who haven't really done electronics before. When you work on your robot, you should turn it off. You must turn it off. Like if you're disconnecting stuff, if you're reconfiguring things, turn it off. Only bad things will happen if you do stuff to it whilst it's on. And the last thing I'll leave you with is that you must remember to charge your battery. You wouldn't believe how many problems we have had in Student Robotics which have just come down to teams having a flat battery. Hours of development time. What's wrong with this? I can't quite work out. Every time we do this, it kind of goes over there and then it just stops. And we have to do it again and again and again. Flat battery, every time. Always the problem. Yes, so, is Jeff here yet?
Hello.
He is!
Hey!
Hey! Jeff's going to come and talk to you about mechanical things now.
We really don't need extra unnecessary complications.
So, Jeff, you're going to come down.
Are you accepting electronics?
Oh, yes, sorry. I'll take some questions from it if you want.
Unless we do
any questions about kit, electronics, stuff?
craft stabilisation, it's not worth it.
Yes.
We still have it as a backup then, in which case it's good as a backup.
So the question is it possible to take multiple images with the webcam first, take like in quick succession, so like a low resolution image and a high resolution image, and then process them separately? Yeah. It is technically possible. I would advise against it because the actual act of taking the picture takes a considerable amount of time. Because what happens with most webcams, like most webcams are set up so that you just turn them on and they start streaming pictures of you. But the thing is that you don't know which frame it sent you was from a particular time. So we don't do that with webcams. What will happen is, webcam is, we have to do that setup every time. So you go to take a picture, and it sets up, it says, give me a frame, and then there's quite a bit of latency there. And so if you want to do 2 pictures with different resolutions, you get that latency, and then you get it again, and then you do processing. So that would actually take you longer, any more questions? There's one from Andy. Sorry?
Mention the token ring.
Oh, I thought I wouldn't mention the token ring because I think you guys will work it out. But you can go to the docs, and you'll find out that all of the boards you're given you connect together in this loop. which we call the token ring. And this page tells you all about it. And you just need to be aware that there's an in and an out port. You need to connect the ins to the outs and the outs to the ins. Any more questions? Or things? Oh, sorry, yes.
I thought it was pointing out motion blur webcams.
Absolutely. So, the important thing about the webcams is that when this marker is moving, they will pick up motion blur. And that's going to distort their picture of this marker. And that means that they won't be able to see it. They won't recognise it. So if your robot's moving, it can't see tokens because everything's blurred to it. And so you will need to stop to take a picture to work out where you are. And also you should be aware that, if there are any other things moving around in the arena, like robots, you might not be able to see them while they're moving. So whilst the vision is awesome and cool, it has its limitations. Any more questions? Yeah.
You need things like Arduino and then with cut off, because otherwise surely you could just end up trying to use the Raspberry Pi or something as the secondary process, which would possibly be overkill.
Sorry.
Well, so if we can use Arduino and then instead, where's the cut off?
Oh, you can use anything you like.